last topic you're going to be responsible for your unit test is even and odd functions. Okay? So again, even and odd functions doesn't mean even degree function. An even function is different than an even degree function. Okay? And you'll see what I'm talking about as we go through the lesson. Because not all even degree polynomials are even functions. And same thing, not all degree polynomials are odd functions. Okay, so let's define what I'm talking about. The first one is an even function. An even function is symmetric about the y-axis. So what that means is if you took a mirror and put it on the y-axis, then the reflection of one side would cover the other side. Okay, so it looks exactly the same thing here. So I'll attempt to draw that as best as I can, show you what I'm talking about. Okay, so say I have a function that looks like this. So I attempt to draw that. If I had a mirror here, then this guy would reflect in this guy reflecting. Okay, so that's what it means for a function to be even. So you can tell graphically whether a function is even is if it's symmetric about the y-axis. What you're going to be responsible for is determining whether a function is an even function algebraically. So a function is, I'm just going to write this out and then I'll read it to you. Because a lot of times math teachers will use symbols and nobody has any idea what they mean and nobody really asks. So a function, an even function satisfies the property okay. So an even function satisfies the property f of negative x equals f of x. Anybody know what this upside down looking A means? Yep. Close. For all. Okay. For all x that exists in the domain of f. Okay. So that just means it's going to work for every single x in the domain. So what that means is, say I had a value here. So this is the same distance away, and this is the same distance away. This is negative a, and this is positive a. If you take negative a and plug it into the original function, or if you take its positive counterpart, a, plug it into the function, you're going to get the exact same answer. And of course, I'll do examples of how to figure out looking at it algebraically. Okay. Let's talk about an odd degree. An odd function, not odd degree, sorry, odd function. An odd function is rotationally symmetric about the origin. And it's rotationally symmetric 180 degrees. So I'll draw a picture of that. Okay, Okay, so rotationally symmetric about the origin 180 degrees. Think of the origin here as like the pivot point, and then you take one side, you're not actually doing it, you're just picturing this. You're taking one side of the function. If I rotate it 180 degrees, it would cover the other side. That make sense? So an odd function satisfies the property f of negative x is equal to negative f of x. So all x that exists in the domain. So graphically what that means is if I have negative a and I plug 1 in, I'll get a value. If I plug the other one in, I'll get the same value, but it'll be negative. So this part here, the property part, this is what we're going to prove, use to prove whether a function is even or odd. So whether the function is even or odd, you'll be given a function. The first thing you're going to do is you're going to plug negative x into the function. And then you're going to simplify it. You'll do some math, you're going to simplify it. If it matches the original function, then it's even. If it works out to be the negative of the original function, then it's odd. If it doesn't work out to be either, then it's not even or odd. Okay, so I'll do a couple examples of that. So this will be very similar to a test type of question. Now you'll be asked whether a function is even or odd. You'll get 1 mark for saying whether it's even or odd. So even if you don't know, if you don't remember this, which hopefully you do, guess. But then you get another mark for actually proving it. Okay, so if you just put even and it is even, you're not going to get 2 marks. You'll just get 1 out of 2. Okay, you have to show why. Okay, so determine if each function is even, odd, or neither. You could spell in here. I spelled neither right? That's right. How about the I before E except after C thing? Doesn't apply in this case? No? Okay. So you'll get a question very similar to something like this. Now there's going to be a point where you're going to be able to, when you do enough of these questions, you're going to be able to look at it right away and determine whether it's even or odd. Okay? But you have to show me algebraic test if you want that extra mark. Okay, so here's my function. I'm trying to determine whether it's even, odd, or neither. So what I'm going to do is I'm going to start by substituting negative x into the function. So I write down the function, just like in the beginning of the guide, right? We're doing function notation. You're substituting negative x in for your x. And put brackets around it. Okay. So that's always your first step. Doesn't matter if it's even, odd, that's the first thing you're going to do. Then you're going to simplify. Okay? So you say to yourself, negative x to the power 4 becomes x to the power 4. Negative x squared becomes x squared. Then I look, the first thing you want to do is look, did I match the original function? Okay? Yeah, so if it matches the original function, then f of negative x worked out to be f of x. That tells me it's an even function. So this guy here, therefore, even. So I'll just do an example of each just so you see how all of them occur. I want to determine whether this is even or odd. So remember that f of x and y are interchangeable. So if they have y, it's okay to change it to f of negative x. Substitute in negative x for x. Now simplify. So negative x to the power 5 will become negative x to the power 5. I take that negative, multiply it by the 6, I get negative 6x to the power 5. Make sense? Okay, the next one, negative x to the power 3 becomes negative x to the power 3. That negative multiplies by that 3 to make it a positive. And I get that. Any questions on how I got that second line? Okay, second line. Does it match the first one? Right? No. So if it doesn't match, you know it's not even. Now you're going to check if it's odd. The way you check that it's odd is you factor out a negative. So you're going to factor out a negative. And when you factor out a negative, this becomes a positive inside the bracket. This becomes a negative. Now you're going to look to see if what's inside of the bracket is the original function. And is it? Correct? Yeah. So it's an odd function. Maybe I can squeeze this in here too. That's the original. So this is going to be your step every single time. So 100% you're going to get a question like this on your test. Probably be the last question, right? You start by substituting negative x in, simplify. The next line, look to see if it matches. If it does, it's even. If it doesn't, your third line should be factoring out the negative. If it matches inside of the bracket, then it's odd. And if it doesn't match, like an example I'll do now, then you would just write down neither. Right, so this is an even degree polynomial, but it may not work out to be an even degree function. Excuse me, an even function. First step, substitute negative x in, simplify. Negative x to the power 4 become x to the power 4 times 4. Two negatives make a positive. That. So I look up, it obviously doesn't match the first function, so it's not even. And the next thing I try is to factor out a negative. If I factor out a negative, I get that. And it doesn't match inside of the bracket, so it's not odd, so you would say it's neither. Any questions on even and odd functions? Again, you should be able to recognize whether a function is even or odd graphically by it's even if you put a mirror here and the reflection on this side would cover the reflection on this side. It's odd if it's rotationally symmetric, 180 degrees, and it has to be at the origin. Okay? So picture you taking this branch, rotating it 180 degrees, and it would cover this branch. Okay? That's how you would look at it graphically. Algebraically, you just follow the two properties. Any questions? Okay, so that's all that you need to be successful for